Welcome to Math Hub S. Today we are going to continue our lessons on indicial equations. As you can see on our screen, we have three questions that we are going to solve. First question is, if 3 exponent 5x plus 3 is equal to 81 exponent x plus 3, find x. Question 2, given 125 exponent x plus 2 equal to 5 exponent 2y, find x in terms of y. Then we have question 3, solve for x if 8 exponent 2x plus 1 is equal to 1 over 512. So we are going to solve these three questions together, and what I'm going to tell you is that you can pause the video and then try solving them. After that, you come and confirm your solution to what we are going to get together. But also consider subscribing to the channel. By doing so, you will help us to grow. Right, you are welcome back. I hope you have done your part. So now we are going to do it together. We are going to solve the questions together, starting from question number 1. So we have solution to our question. But before we even move on to solve the question, I want to explain some few things here. The sign that we have in the question is an equal to sign. As you can see here, this is an equal to. And whenever you have an equal to sign, it means that the left side is the same as the right side. That is, the value of the left side is the same as the value of the right side. That's why you are seeing an equal to sign. Now, if it is greater than or less than, then it means that they are not the same, right? But once you see an equal to sign, it means that the value of the left side is the same as the value of the right side. For instance, I can write 4 is equal to 4. I can also write 8 is equal to 8. And I can write 16 is equal to 16. I cannot write 16 is equal to 8 because they are not the same. The 16 and the 8 are not the same. We only use equal to sign when the right side is actually the same as the left side. That's the instant that we use the equal to sign. So from here, I want to use these numbers to explain something before we even start solving our question. In terms of indices, this 4 here, can write it as 2 exponent 2, then equal to 2 exponent 2, and that is the 4. So if you look at this one, you see that the bases are the same. We have base 2 and we have base 2. Then we have exponent 2 and we have exponent 2. The next one is, it can be written as 2 exponent 3, then equal to 2 exponent 3. So also you see that the bases are the same, 2, 2. Then the exponents are also the same, 3 and then 3 at this place. Then for the 16, you have 2 exponent 4, that is 16, is equal to 2 exponent 4. And we see that the same place, this place, the bases are the same. And then the indices are also the same. Now if you come to the last one, you have 16 is 2 exponent 4. And then you have 8 is 2 exponent 3. So here you see that the bases are the same, 2, 2, but the index are not the same. The index here is 4 and the index here is 3. You see that because the indices are not the same, that's why the value at the left side is not the same as the value at the right side. Also, if the indices are the same and the bases are different, the left side will also be different from the right side. For instance, if I have 2 exponent 2 and then I have, let's say, 3 exponent 2. 2 exponent 2 is giving me 4, and then 3 exponent 2, which means 3 square or 3 times 3 is giving me 9. So you see that 4 is not equal to 9. Right, so if the bases are different and the indices are the same, the right side will not be equal to the left side because of the difference in the bases. And also, as in the case of this one, if the bases are the same, that is this place down here, if the bases are the same and the indices are different, the left side and the right side would not be the same because of the difference. So the only case that we have the left side and then the right side being the same is both the bases and that of the indices are the same. If the base at the left, if the base at the left is equal to base at the right, is equal to base at the right, and then index at left is equal to index at right, index at right is equal to index at right, then we can say that the left side is equal to the right side because both the bases and that of the indices are the same. Right. So now with this concept, we can proceed to solve our question. So that means if we are able to make the base of the left side and that of the base of the right side to be the same, then we can equate the index of the right side to the index of the left side. Because once the bases are the same, then the indices must also be the same. For the sign here, the equal to sign to hold. For the equal to sign to be true. If not, it will not be true. So we are saying that once the bases are the same, then the index of the left side must also be the same as the index of the right side. That is, should be equal to the index of the right side. So we have 3 5x plus 3 equal to 81x plus 3. Now, if you look at the two bases, we have 3 and then we have that of 81. You see that this is 3, and this 3 cannot be expressed in terms of any other prime number because it's already in the basic form. 3 is already in the basic form. You have to consider the 81 and ask yourself whether you can express the 81 in terms of 3. That is, you can write 81 in terms of base 3, right? So if you check the exponents of 3, you see that 3 exponent 4 is going to give you 81. So that means that our 81 can be expressed in terms of base 3 as 3 exponent 4. So here we are saying that 3, that implies 3 5x plus 3. Then using this 3 as a guide, we can express the 81 also in base 3 as 3 exponent 4. Then we have here 3 plus x. So open bracket 3 plus x or x plus 3. So now you see that the base here is the same as the base here. So we can proceed. 3 5x plus 3 is now equal to 3. So here I'll multiply the 4 by the x in the bracket. I'll also multiply the 4 by the 3 there. So I get 4x plus 12. That is 4 times 3. So at this point we have the same base, that is 3 and then 3. So once we have the same base, for the condition to be true, that is for the equal to symbol to be true, then this place, that is the index of the left side, must be the same as the index of the right side. If not, the equation will not hold. It will not be true for the equation. In other words, it cannot be an equation if the index of the right side and the index of the left side are not the same. So for the equation to be true, since the bases are the same, then the indices must also be the same. So we are saying that means that 5x plus 3 should be the same as 4x plus 12. So we are solving for x. As here you can see, find the value of x. So to solve for x, here is 4x and here is 5x. So I'm going to subtract 4x from both sides, and then I will also subtract 3 from both sides. So if I subtract 4x from both sides, I'm going to get 5x minus 4x at this side. Then I'll also subtract 3 from this side. So 3 minus 3 will be 0. I'll not write it. That will be 0. Then equal to, I'm subtracting 4x from both sides. So here too, I'll subtract 4x from here. And if I subtract 4x from this place, I'm going to get 4x, then minus 4x. That will be 0. So I'll write the 0. Then I'm also subtracting 3 from here. And that is going to give me 9. Then from here, I'll get here to be x equal to 9. That is 5x minus 4x is giving me 9. So our value for x is 9, and that means that if you substitute 9 into 5x plus 3, and you also substitute 9 here, 4x plus 12, the answer that you are going to get for this right side is going to be the same as the answer you are going to get for the left side. So our value for x is 9. Now we move on to example 2. So we have our question 2, which says that given that 125 exponent x plus 2 is equal to 5 2y, find x in terms of y. So we are going to find x in terms of y. Now find x in terms of y simply means that make x the subject. So we are going to make x the subject. That's what we mean by find x in terms of y. So we start from here. This is an equation. So let's say solution. So we have 5 here, and then we have 125. The 5 is already in the basic form. You can't express it in terms of any other factor. So already the 5 is in the basic form. Therefore, we use this 5 as a guide and see how we can express this one in terms of base 5. So we are using the 5 as a guide, and then based on the 5, we are going to express this 125 in terms of base 5. That implies 125 is the same as 5 exponent 3. 5 exponent 2 is 25, and then 5 exponent 3 is 125. We now bring the bracket, which is x plus 2, then all this is equal to 5 2y. So from here, we can multiply the 3 through what we have in the bracket, and that means 5 3x, then 3 times 2 is 6. That is equal to 5 2y. From here, we see that our bases are the same. We have the same basis, that is 5 and then 5. So once we have the same basis, then our indices must be the same. If the indices are not the same, then the left side will not be equal to the right side. So for the left side to be the same or to be equal to the right side, then this place 3x plus 6 must be the same as 2y. So we proceed from here. This implies, since the bases are the same, means that 3x plus 6 must also be equal to 2y. Note that the question is find x in terms of y. So we are going to make x the subject from this place. And we can proceed by saying 3x is equal to 2y minus 6. We are looking for x, so divide by 3, and here divide by 3. So our 3 here cancels 3. We have this 3, cancel this 3, and then that implies that our x is equal to 2y minus 6 all over 3. So, and that is example number 2. How to solve example number 2. And now we move on to example 3. So our last question for today is solve for x if 8 exponent 2x plus 1 is equal to 1 over 512, right? So we start with solution. Now if we consider the basis that we have here, we have this one as 8, and this one we have a fraction here which is 1 over 512. But we have the denominator here which is 512, right? First of all, you notice that 8 is not in a basic form. That is, 8 can be expressed in terms of other factors. For instance, 8 can be expressed in terms of 2. Since 8 can be expressed in terms of 2, 8 is the same as 2 exponent 3, that is 8. So we can express this 8 in terms of 2 as 2 exponent 3. Once we can express the 8 as 2 exponent 3, we also check to see if we can express 512 in terms of base 2. Maybe 2 exponent what will also give us 512, right? So you have 2 exponent 3 giving you the 8. So you ask yourself, can you also express 512 in terms of 2? Then you check for 2 exponent what value, that will give you 512, right? Also, you can leave the 8 as it is and check to see whether you can express 512 in terms of 8. That is, whether you will get 8 exponent something, right? 8 exponent something, that will give you 512. 8 exponent what number, that will give you 512. So if you try 8 and 8 doesn't work, then it means that you have to rely on the 2, right? You have to check for the 2. So if we check for 8, 8 exponent 3 will give you 512, right? So you can decide to go direct and use the 8. Instead of breaking this 8 into 2, you can go ahead and say 8 2x plus 1 is equal to 1 over 8 exponent 3. That is a 512. Now from here, 8 2x plus 1 is now equal to 8 negative 3. So note that 1 over 8 exponent 3 is the same as 8 exponent negative 3. For the explanation is very simple. The one which is the numerator, we can write it as 8 exponent 0. 8 exponent 0 is 1. Then over 8 exponent 3. That is the denominator. And this one here, by the indices law of division, since the bases are the same, we subtract the denominator from the numerator. So that will be 8. And then we have 0 minus 3. So 0 minus 3 is negative 3. So you have 8 negative 3, which is the same as what we have here, right? So we are saying that this one here is the same as 8 negative 3. So here, once the bases are the same, we have 8, and here too we have 8. We can now equate the exponents, and that means 2x plus 1 is equal to negative 3. Then we have 2x is equal to negative 4 plus 1 here. So I'll subtract 1 from both sides. So if I subtract 1 from here, I'll get 1 minus 1, 0. Then I'll subtract 1 from here, and that will be negative 3 minus 1. That will be negative 4. So I have that. Then I can divide by 2. So this will cancel out. Then here too, I have that implies x is equal to negative 4 divided by 2. Negative 4 divided by 2 is negative 2. X is equal to negative 2. So let us express the 8 into base 2 and also express this one. So if we are doing that, the 8 can be written as 2 base 3, then we already have 2x plus 1, then that will be equal to 1 over, then 512 can be expressed as 2 exponent 9. That implies that we have 2, then we can multiply our 3 through the bracket. That will be 3 times 2x, which is 6x. 3 times 1 is 3, then equal to 1 over 2 exponent 9 is the same as 2 exponent negative 9. And the explanation here is very simple. If you consider the 1, we can write the 1 as 2 exponent 0. Every number exponent 0 is 1. So this one we can rewrite it as 2 exponent 0. Then dividing by 2 exponent 9. From here, by the indices law of division, once the bases are the same, then you can have your base and subtract the index of the denominator from the index of the numerator. In this case, the index of the numerator is 0. Then the denominator is 9. 0 minus 9 is negative 9. So you get 2, then negative 9, which is here. Right. So we are saying that 1 over 2 exponent 9 is the same as 2 exponent negative 9. So we can proceed from here. Now we have the same basis. The bases are the same. We have 2 and 2. So for the right side to be equal to the left side, then the indices must also be the same. That is, for the equation to be true, then the indices must also be equal. That is, 6x plus 3 must also be equal to negative 9. And from here we can solve for x. That is 6x. Now from here we are subtracting 3 from both sides. So if I subtract 3 from here, I'm going to get minus 3 here, and that will give me 3 minus 3, that will be 0. I will also subtract minus 3 from here, and that will give me negative 12. So I have negative 12. Now we say that we are dividing by 6. So here 6 cancels 6, and then 6 cancels 12. So you have x is equal to negative 2. So you see that whether we use base 8, we express 512 in terms of base 8, or we express both 8 and that of 512 in terms of base 2, we are going to get the same answer, which is negative 2 for x. So it doesn't really matter which way you take, but what matters is that the procedure should be right, and once the procedure is right, your correct answer is granted. So we end it here, and I'll urge you to subscribe for more interesting lessons. Goodbye.